AI can write essays that sound human. AI can generate code in seconds. It can generate images or videos. It can translate languages and answer complex questions. For many people, this feels like a new kind of intelligence. Something very closer to thinking, something closer to understanding. But here is the surprising part. The core idea behind today's AI is not very different from the early AI systems. To understand the modern AI, we don't need to start with the neural networks. We need to start with the first place. That was chess engines. Deep Blue defeated Garry Kasparov. One of the first time AI felt genuinely intelligent when it started playing chess well. Not just playing, but beating human champions. At first glance, this looked like AI thinking of strategy, planning the next move, foreseeing the outcomes. But under the hood, something simpler was happening. The chess playing AI didn't understand the game the way humans do. It didn't know what a good position meant in a human sense. Instead, it did two things. It evaluated board positions and it predicted outcomes. Given a position, it asked a very simple question. If I make this move, how likely am I to win? It explored many possible futures and chose the best move, with the best predicted result. That details matters. Because even at this early stage, AI was not thinking in the concept. It was predicting the outcomes. The system didn't care why a move was strong. It only cared that across many possible futures, this move led to winning more often. That's a prediction, not understanding. Now, here is the key insight. From chess engines to modern AI systems, the core intuition stayed largely the same. Predicts what comes next. Choose the most likely or most favorable outcome. What changed was not the idea. What changed was scale. Early chess programs operated in a small closed world, had limited computational capabilities, explored fewer possibilities. Modern AI systems operate in a massive open domains, have enormous computational capabilities, learn from vast amount of data. But intuition is still prediction. Chess predicted the next move, language model predict the next word, image models predict missing pixels. Different domains, same core idea. Now let's compare chess and language. Chess is a clean system. It has clear rules, clear goals, and clear outcomes. Language is very different. It's messy, it's ambiguous, and it's highly context dependent. Imagine you are given a chessboard position. In chess, it doesn't matter how you reach that position. The best move is the same. But in language, past context matters. Previous sentences change what comes next. And yet, modern AI approaches the language using a very similar intuition. Given a sentence, the system asks what word is most likely to come next. It doesn't ask what does this sentence mean? What does this speaker intend? What is the real world situation? It predicts continuation. Change the sentence and entire prediction is changes. Not because system understand the situation, but because pattern distribution shifted. That's powerful. That's why language models feels impressive. Language touches everything. Science, emotion, reasoning, creativity. So prediction in language often feels like intelligence. But under the hood, it's still pattern continuation, just on enormous scale. There is one limitation that has remained remarkably consistent. From chess engine to today, AI does not know what it does not know. In chess, the system always chose a move. In language, the system always produces an answer. There is no internal steps where it asks, is it enough context? Should I answer? Am I guessing? Once input enters the system, an output will come out. That's why AI can sound confident even when it's wrong. Not because it's careless, because the system is doing exactly what it was designed to do: predict. Humans build intuition by acting in the world. We make mistakes, we experience consequences, we adjust. This feedback loop, action, consequence, learning, is how common sense forms. Prediction systems don't live in that loop. They observe outcomes, they don't experience them. This is a crucial difference. Humans learn by being wrong. AI learns by being adjusted. They sound similar. They are not. From chess to today, AI systems learn pattern about the world, not what it feels like to act in it. That's why common sense failures haven't disappeared with scale. They were never a data problem alone. They are a system design difference. AI didn't suddenly become intelligent. It became predictive at scale. Once you understand that intuition, AI becomes less mysterious and more predictable. And that's what we will keep building here. Not explanations, not hype, just intuition layer by layer.